Hello everyone and welcome to the coding manual, and today we are going to solve the problem number of island, and the ID is 200. So let's get straight to the point. And the question says, given a 2D grid map of one's land and zero's water. So one represents the land and zero represents the water, and count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, so if we look at this uh, example, so it says a grid is given 1 1 1 1, and then uh, okay, so according to this grid, so whatever is the one, it represents the land, and adjacent to that also represents the land. So this particular grid is connected. Okay, this particular grid is connected till here. I mean, first row till fourth column, and second row till second column. Third row till second column, and other thing are water. So this should be answer 1. Okay, so the output is 1. Now let's get to the other example so that I will try to explain with this one. So this I have written, so 1 1 1 1, and so this is fine. Okay, yeah. So I have represented this land as green 1 and water as blue zeros. So what do we have here? So when we start, so one land is, one island is here, one island is here, and another island is here. So adjacent, like it said, vertically or horizontally, lands are connected. Vertically or horizontally, lands are connected. So we need to find out the total number of island in the this grid. Okay, now this question uses the concept of BFS and DFS. Okay, so and today we will primarily focus on BFS, and I'll make another video in future which will use DFS, but today we are going to solve this using BFS. Okay, now just think about it. When you use BFS, what do? We traverse till, means, at any particular point of time we traverse all the way to its adjacent, means every side. So what will happen, when we are at this particular grid, so we will traverse here and here. Okay, and see if they are land or water. If they are land, so we will again traverse its adjacent. Like if we reached this point, so we will traverse this, traverse that, traverse the right, and traverse below. In all possible direction we will traverse and see what they are. Okay, so and one simple trick to use here is, when you are at particular index, particular grid, when you traverse that, just make it something else so that you don't mess up with, you don't end up being in a cycle. Okay, just like if I try, so what I want to say is, if I'm at this point, suppose this is at this point, and I traverse here, and one is here, one is here. Let me make it little big. Okay, one is here and zero. If I'm at this point, I traverse this, I need to go up direction, down, back left, and down and right. And if I don't update this, so what will happen, when I end up going right side, its left side is again 1, so I'll end up being in a cycle. So that we can avoid by changing its value. Okay, and in BFS, as all we know, BFS primarily uses queue. Okay, whenever there is a DFS, we will primarily think of stack or recursion, but whenever there is a BFS, we normally use queue. So what happens in queue is you put things in the queue and pop from the uh, left. And I mean, it is something like you push everything to the right, and whenever there is a pop, you pop from the left. It's like a push to the front and pop from the back. Okay, so I think primarily this will be very helpful when we do using code. So let me write the code here. Okay, so suppose if grid, the grid what we have, if that grid is empty, if that grid is empty, if grid doesn't exist, so we have to return 0 because there are no island. Otherwise I'll have rows at length of what is grid, and then columns as length of grid 0, and then I'll make a queue as dq, and then I'll have something to count the total number of total islands. Okay, now traverse everything. For I in range of rows, for j in range of calls. Okay, if grid of I comma j equal 1, so it is represented by string, so we can directly check with string. Whenever there is, when you encountered one, any one, you are count counting the island islands plus 1, and then you make that particular grid something else, because we do not want to end up in a circle. Okay, we do not want to end up in a circle, and since this particular the grid this particular grid was 1, I have to look for its adjacent, just like this. Since this was this was our grid and we encountered 1, I encountered 1, so I have to look for this direction and this direction. Okay, uh, whether it's there is land or not, whether downside there is land or not. So what I will do, I will append that particular q dot append that particular as a point. Okay, in the queue. Now until unless that queue is not empty, length of queue, I will say point is q dot pop left, and then I'll say row equal to point of 0 and calls is equals to point of 1. Okay, now I'll check in all direction. If row minus 1 is greater than 0 and grid of row minus 1 and call. if that is 1, then I have to push that point to Q. Row minus, that will be in the list. Row minus 1 comma call, and then again this was up, this was in the same grid on the upside. Okay, I was here, so I checked this side, but this is not 0, so we'll avoid that. Is that greater than or equal to 0? Row was 0. What was row? I, J, and then we had a, we ended appended the 0 0, we appended the 0 0, and we got 0 here, 0 here, and then 0 minus 1 greater than 0, greater than or equal to 0. No, so we will skip that, line number 20. Okay, now same thing goes for if row plus 1, we are checking down now, row plus 1 is greater, here we will check if we are, we will check if we are not exceeding the row, if we are not going beyond that boundary. So what we will have to check is if that is greater than, less than what is the row, rows, and grade of row plus 1 same column is 1, then we have to append that row plus 1 call. Okay, now all 4 direction we have to check, so I will check call plus 1. Call plus 1 is less than calls and grid of call, plus grid of row, the current row and next call plus 1 equals to 1, then q dot append of, yeah, so we have to append row and call plus 1. Same thing goes with call minus 1, call minus 1 is greater than or equal to 0, and grade of row call minus 1 equals to q dot append of row call minus 1. Okay, and then we are done. We have to return total islands. Okay, hmm. Time limit exceeded. Oh yes, so that each of that we have to update. As I was saying, we do not have to end up in cycle, so everything of that will become 0. Same goes with grid of row plus 1 of call is equals to 0, grid of row and call plus 1 equals to 0, and then grid of row and call minus 1 is 0. Just um, I'll make it little big so that it's visible. It looks horrible, but it's a very simple code. We just need to understand how we are doing this part. We started from this. We check in all direction. If they are 1, we append that particular coordinate in the queue and make that particular as 0. The one we the grid that particular grid we visited, that coordinate we make it 0 if it was 1, and if it is 1, so we push that in queue, the particular here, and we make that 0 because anyhow this queue will be looped until it is not empty. This particular case, while queue is not empty, we are going to traverse that. Okay, we are going to traverse that, and that's why we whenever we are appending any particular coordinate in the queue, we have to make it 0 because it's kind of visited and non-visited. So whenever that particular coordinate is visited, just change its value to 0. Okay, just think about this code, just analyze. I think it's very easy, and it should be accepted. Yep. So this is success, 152 millisecond. So this is relative. Probably the very very first person who might have submitted the same code might have got it uh, faster than 100% people because there was no code. And I hope you liked it, and if you think something needs to be improved, please let me know in the comment, and please like and subscribe to the channel. Thank you for watching.